Hey everyone, welcome to my channel. In this video, we are going to create this awesome project where we can find the distance of a face from the camera. So you can call it distance or depth. For example, you can see here the depth is 66 centimeters right now. If I move forward, you can see the depth is decreasing. If we move backwards, the depth increases. So all of this is done using a single webcam, and we are not using any depth sensors. And on the right hand side, you can see an application for this. Right now, you can see it is flickering a lot because I'm moving my head again and again. But the idea is that if I go backwards, the size should increase so that it is easier to read. And if I come forward, the size should decrease so that it is more appealing to read because you are close to the camera or to the screen. So this is the basic idea, and you can do the same thing with volume as well. So if you are close to the screen, the volume should be lower. If you are at the back, then the volume should be higher. Right now it is shaking a lot, so let me show you how we can fix this. This is the sensitivity. For example, we can put it at 25 and the shaking will be much lower than before. So let's see. There you go. Now it's not shaking that much. And if I go back, it increases. If I go further, it increases as well. So you can basically limit the sensitivity of the project. So this is our project for today. It is very exciting. And if you want to really level up your skills, if you like these projects, then do check out our premium courses, which are available on our website. They will help you step by step to go from a beginner stage to a more advanced stage where you can build your own ideas, your own practical applications. And it will really help you get from the basics to the advanced topics. Anyways, let's go ahead and start our project for today. So here we are in our PyCharm project, and the first thing we will do is go to File, and we will go to Settings, and we are going to install our packages. So we'll go to Project, we will add the interpreter, we will click on Settings, Add, we will set the existing, and then we are going to add the CV Zone package. And we are also going to add the media pipe package. So make sure you are using the correct versions. So if there are updates on these versions, you can use those. But if it doesn't work properly, if it gives you a lot of errors, you can come back to these versions. So it is 0.8.91. And for the CV zone, we have 1.5.4. So these are the version numbers that you should use if you want to follow exactly the same way. Otherwise, installing the latest version should not be that bad. So CV Zone is already installed and we are waiting for the media pipe. So hopefully it will be installed momentarily. And then we have our face depth measurement project. So we are using the PyCharm IDE, as you can see, and the name of the project is face depth measurement. So what we are going to do, okay, so the installation is done now. So the first thing we are going to do, we are going to create a file. So we are going to call it, let's say, face depth measurements. Okay, so here what we will do, first of all, what we need to do is we need to get the points of the face, and we need to get the landmarks, and based on those landmarks we are going to estimate the depth of the face itself. So we are not talking about objects here, we are talking about a particular face. So we need to find something that is common, mostly common across all faces. So it could be any measurement that we can use. So once we have that measurement, then we can use this formulation. So let me just explain what is going on here. So first of all, we have our camera here. As you can see, this green region is the camera, and then we have our object. So the camera is looking directly to the object, and the width of the object is given by the capital W. So here you can see the capital W is the width in centimeters. So this is in real life, the size of the object. Then we have a smaller width, which is basically width in pixels. So within our image, we will see the object. So let's say this is our image, and in that we are going to see the object. And what is the pixel size or the width of this object? That is basically the small w. Then we have a focal point. So this is our focal point, and we have a focal length. This focal length is given by f, and it is basically the distance from here till the edge, till the focal point. So this is what we need to find. And d is the distance, the actual distance or the depth between the object and the camera. So our end result is d. We want to find the depth or the distance. But before we do that, we need to calculate the f, the focal point, the focal length. So in order to find the focal length, we are going to use this formula. So the focal length is given by the smaller width multiplied by the distance. So we have to do it for an object which we know the distance of. So we will place the object in an area where we know that this is how far the object is from the camera. And then we will also know the width of the object in centimeters, and we will find the width of the object in pixels, and based on that we will get the constant value of f, which is the focal length. And once we are done with this calibration, finding the focal length, then we will apply the formula for the distance, which is just rearranging this formula, and we get w multiplied by f divided by the small w, which is your pixel value. This is the centimeter value, and this is the focal length that we found. So we are going to go and do step number 1 to find the focal length, and step number 2, once we find the focal length, it will be constant, so we will not apply the formula again, and we will keep checking the distance again and again, because the f, the focal length, will be with us. So this is the basic idea. This is what we are going to use. Now the object in our case should have a constant width. So if you think about the face dimensions, there are some values that are constant. So they are not completely consistent with every face, but they are very close to each other in most cases. So one of these values is the distance between the eyes. So when we are talking about the distance between the eyes, this is what we mean. So from the center of the eye to the other center of the eye, and the average value for men is 64, and the average value for women is 62. So what we will do is we will take an average of that, and we will use the value of 63. And again, another value that you can use is basically the iris, which is the circular part within your eye. So that actually remains constant as well. It doesn't fluctuate a lot, but detecting that is a little bit harder. So what we will do is we will check the distance between two eyes, and that will be the object of interest. And based on that, we will define how far our depth is. Again, this will not be perfect, but it will work to a certain extent in controlled environments, so it should be good enough. So let's get started. The first thing we are going to do, we are going to import our libraries. So we will write import CV2, and we will write import CVZone, and then we will import the face mesh module. So we will write from CVZone dot face mesh module import face mesh detector, and then we are going to create our webcam object. So cap equals cv2 dot video capture, and we will give in the value of 2. Now for you it will be different, because most probably it will be 0. I have multiple cameras installed, so that's why I have to use number 2. Then we will write while true, we are going to write that our success and the image equals cv2 dot not cv2 cap dot read. So then we will write cv2 dot wait key is 1, there will be a 1 millisecond delay, and we have to write cv2 dot what do you call IM show, and we will write image and img. So this is pretty standard, that's why I'm not taking a lot of time here. So this should be easy to follow, and if we run this now, you should see my webcam. So let's see if we get anything. There you go. So now you can see my webcam directly here. We will close this, and now what we are going to do, we are going to find the face. So to find the face, we are going to write here detector equals face mesh detector. And do we have to give, yeah, let's give maximum faces as 1. So we don't want multiple faces, we just want the one face. Okay, so that should be good. And then we have to write detector dot find face mesh, and we will give in our image, and that will return us with the image, and it will also return us with the faces. So let's go ahead and run that. There you go. So now you can see my face is detected and it is working fine. So what we can do next, I don't like to draw this. So what I like to do is draw equals false, because there's just too many points. It's 468 points. So I don't see the point of that. Okay, so now it is good. And what we need to do next is we need to find the points of our eyes. So once we have those points, we can find the distance of the distance between the eyes. So if you remember in our previous tutorial as well, we started off with the different points, where exactly they are. And I have checked what exactly is the value for the points, and we are directly going to write it down here. So let's just write it here. So we will say that if any face is available, so face will be equal to faces at 0. So we will take the first face, and because we know our maximum faces is 1, so this will always be true. We don't have to worry about other faces. So face equal faces, now we have our face, and then we need to detect the landmark. So we need to tell which points do we need. So for this example, we need 2 points. We need points for the left, and we need point for the right. So the point of the left is basically the value 145. So let's just draw it. So cv2.circle image, and what else? We need the center position. The center position will be point left, and the radius, let's say 5, color, let's say 255, 0 and 255, which will be purple, and cv2.filled, so it will be easy to see. So let's run that. There you go. So now you can see one of the points on my eye. So this is, let's say, for the left one, and then we are going to get it for the right one. So point right equals face at 374. So again, these numbers I have tested earlier, and these are the ones that we are going to use because they align, mostly they align with the center. So here we will write point right. So let's try that. There you go. So now you can see 2 points right between my eyes, and now we need to find the distance between these. What is the length of the distance? And what we will do is, first of all, let's draw a line. cv2.draw, cv2.line, and then we will put image, and then we have to give in point 1. So point 1 will be point left, point 2 will be point right, and the color again we will use, or let's use green. So 0 to 100 and 0, it will be a little bit dark green, And thickness, let's give it 3. Let's try that out. Okay, there you go. So now we are getting our points and we are getting the line as well. Actually, the line should be before this. So yeah, that looks better. So now we have the 2 points and we have the line. So this is the distance between the eyes. So this will pretty much remain constant. So whether you go back or forth, in reality, and of course in pixel values, it will become bigger and smaller. And based on that value, we will determine how far are we from the camera. Okay, so now we need to find the distance, the distance in pixels, which is basically our W small. So we will write here that W small equals, or should we write it, let's just write it W. So W small is equal to, we are going to write detector dot find distance, and we will write point left and point right. So yeah, that should be good. And I think we need to give in the image as well, but we are not really drawing, so I don't think we need that. Okay, so let's see if that works, and we can print out the value of W. Print the value of small w. So keep in mind we have a capital W and a small w, and there you go. So it is returning multiple values, so we will put an underscore here. We will ignore the rest of them. So there you go. So now we are getting the distance in terms of what do you call pixels. So this is the distance in pixels. So now what we need to do is, if we go back to our equation, so if we look at our equation, it basically requires the W small. We already have that. We have taken it from our, what do you call, image. And then the distance we will set, okay, I am, let's say 50 centimeters from the camera. So I will put that as 50, let's say, and then the width of the actual eyes. So what is it in centimeters? So the average value that we have decided upon earlier, which is the capital W, is basically 6.3. So as I mentioned before, it's for females, it's 62 millimeters, and for males, it is 64 millimeter. So we will use 6.3 centimeters. So we are doing everything in centimeters. So we are putting 6.3. So we have the small w, we have the capital W. Now we need the distance. So the distance is basically 50. So in our case, the distance is 50. Actually, let me write down here. We are finding the focal length. So we are finding the focal length. So now we can put our formulation F equals, if we go back here, F equals W multiplied by D divided by W. So small w multiplied by D divided by capital W. So that will be our focal point. So we can print it out and see what that is. But before we do that, what we need to do, we need to make sure we are 50 centimeters from the camera. So I have this measuring tape, and what I will do is I will stay away from the camera almost at 50 centimeters, and that will give us an accurate reading. So I will come a little bit closer, so to make it 50 centimeters. Actually, my table is, the edge of the table is almost exactly at 50. So this should be easy. By the way, I have checked the values before. So let's see if we get similar again or not. So right now, I am at 50 from the camera. And this is the average, what do you call, value. And the focal point is basically, the focal length is around 800. So I didn't prepare a lot, so it might be a little bit different. Here I can see when I did with a little more focus and accuracy, I got 840 something. So right now, yeah, so at this point it's 825, 830. So if you do it more carefully, you will get a better value. So we will keep that value as, let's say, 840, which I found earlier. So because right now I didn't measure properly, so we are going to not rely on this. So the value was 840. So we will write here finding the distance or the depth, whatever you want to call it. So f will be 840. So this will be the focal point. And now our equation will be a little bit different. We will have the same d and w, but our equation will be, no, not the d, of course. The d will be different. We will have the same w. So what we can do, actually, let's put it outside. And we will push this in. And we can comment this out because we will not need it anymore. And here we will write finding distance. Now the equation, if you look at it, is basically d equals w multiplied by f divided by small w. So w multiplied by f divided by small w. So we will, this w is capital, so we will write here that the distance equals this. So this is the distance that we have. Do we need anything else? No, should not be. Let's see how it works. We didn't print it, so we need to print out the value. So print the value of d, the distance. Let's see how that works out. So there you go. If I go back, it's around 75. If I come close to the table, right about 50. So yeah, it is 50. That's good. So if I go back, detecting the values properly. So it's not that bad. Again, you cannot expect it to work similar to an actual depth camera, but it is not bad to work with, and with a decent amount of accuracy. So you can play around with a few applications. So what we can do next is we can print this value out, and to print it we can write cvzone dot put text rect, and we will put it on our image, and then we need to give in the text. So we will write, or let's write an f string. We will write here that this distance, or let's say the depth, is brackets, and we will put the value of d, and we will write centimeters. And then we are going to give in the position. So the position, actually, we want to move the value with the face. So at the top, at the forehead, we have the value of 10. So the ID 10 is right at the forehead. So that is what we are going to use. So the face at 10. So we will write here the face at 10 and the face at 10. And this will be the first element, and this will be the second element. The reason I wrote it like this, so that we can add and subtract some numbers from it. So let's just put it and see what happens. And if it's not good, we will change it. There you go. Okay, so it is very big. So let's just add the scale first. So scale, let's say, is 2. Yeah, I think that's good. We can convert this into integer so that we don't have those annoying decimal numbers. Yeah, so that's better. And we can push it a little bit on the side, and we can push it a little bit higher. So that's why we did this. Actually, let's bring it down a little bit. So let's bring it back a little bit. Let's say minus 75. And let's say this one, we need to push it up. So again, we will write minus, let's say 50. So let's go. Yeah, it's perfect. So yeah, so if I move back and forward, you can see the value is changing. So that is good. And I think the line over here we can remove. So this all is for drawing. We can remove this part. If we need it, we can turn it on back. But for now, I think this will be fine without that. Yeah. So this looks good. Maybe a little bit on the left. Minus 100 maybe. Yeah, now it's right in the center and it makes sense. So that is good. We are getting our depth. Now, this is how basically you can find the depth of a face using the face mesh module. Now, what we are going to do is we are going to apply this in a real world application, which is actually fairly good and it is quite useful as well. So what exactly is the application? What we are going to do, we are going to increase and decrease the size of text based on how far the person is. So if the person is close, the text should become smaller. If the person is going back, if they are further from the screen, then the text should become bigger so that they can read it easier. So, and you can do the same thing with sound as well. So for example, if the person is moving backwards, you should increase the volume so that they can hear it. And if they're coming closer, you should decrease the volume. So you can say it is kind of adaptive or dynamic volume control, which is a pretty cool application. So in this case, we are going to do it with text, but feel free to do it with what you call volume. And I have done a video before in which we use the finger movement to increase and decrease the volume. So if you want to take some ideas from there, how to change the volume, go ahead and do that and try to add it up with this. So it will be quite useful to see as well. Okay, so let's copy all of this. Or let's just copy it here. So let's duplicate this and we are going to change the name and we will say dynamic text reader. So the reason is that sometimes you just want to detect the depth. So you have a separate code for that. It's not mixed up in the project. And the project itself is a different file. So I believe that will be better. Okay, so we have pretty much everything to get started with the project already. We don't need to write the focal length part. We can remove that. And we can also remove the drawings. We will not be needing those. And what happened there? I typed something there. Okay, so yeah, that's pretty much it. Now what we need to do is we need to create an empty, what do you call, window. And in that empty window, we are going to write some text. So to create an empty window, we are going to import NumPy. So we will say import NumPy as np. And over here, once we have our image, we are going to create another image of the same size, but all zeros. So it will be a black image. So here we can write that our image for the text equals numpy dot zeros like our image. That's how simple it is. So it will give us this image text, and what we can do is we can actually should we do it now? Actually, let's do it now. So we will stack them together. So I want both the images to be in one window. So we will write here that our image stacked equals cvzone dot stack images, and we are going to stack the image and the image text side by side. So it will need two columns and we will put the scale as 1. So 100%. And then we are going to just display the image stacked. So it will have both the images embedded in that. So let's run that. And oops, nothing happened. Oh yeah, we are running the old code, so we need to run the dynamic text reader. Okay, there you go. So on the left side, we have our depth, and on the right side, we are going to add the text. So when I come closer, it will become smaller. When I go back, it will become bigger. So that's the idea. So now that we have this, we need to add the text. What exactly are we going to add? So I have written it down earlier. So we will call it text list. And because we need to put it in different lines, we will put it in a list, and it's not just a string. So it will be multiple strings, and we will read each one of them and put them line by line. That will be easier. There are other ways to go about this, but this is one of the easiest ways to do it. That's why we will do it like this. So here we are going to write the string. So we will write welcome to Murtaza's workshop. Okay, that will be our first statement. And this actually is quite big, so we are going to put it in two different strings. Then for the next line, we are going to add here we are, or here we will study computer vision, robotics, and AI. So this part again, we are going to break it down. Then computer vision, this part as well, we are going to break it down. Robotics and AI. And then we can write, if you like this video, then like, share, and subscribe. There you go. So if you like this video, then we will put quotations here, like, share, and subscribe. So like and share will be one, and then this will be another line. So I know there's a lot of strings over here, and this is necessary in this case because the way we are using it. Let's put a dot here and a dot here. Okay, so now in order to run it, what we have to do now, we don't want the text to appear if there is no face. So imagine this, that if somebody is moving and they're looking at the screen, then it should show them the text. If they're not looking at the screen, then it will not show them the text. Or if nobody is around, it will not show. Of course, you can change based on your requirement, but for us, we will do it like that. So we will write here for text in text list. We are going to write the text. So how can we write it? We will simply write cv2.putText. We'll put it on our image. Then we will give in the text. We will write text, and then we have to give in the origin. So let me check the origin. That will be good. The origin will be, the width will be 50. So the height will be dynamic. So first of all, we will put a 50 pixel margin at the top. So it will always start from 50. It will not go below that. So that is our 50. Plus we are going to add a value that represents the height of every single line. So let's say this is the single height equals to, let's say, 50 as well. So what we will do is we will multiply the I multiplied by our single height. But what is this I? I is the iteration number. We don't have it here. So we can write enumerate, and that will give us the value of I. So we will write here I. So it will tell us which iteration number it is running at. So we will multiply the iteration number with the single height. So for example, if the height is 50, for the second one, it will be 100. For the one after that, it will be 150. So, and so on. So this is the idea behind the height. And then what do we have? What is happening here? Yeah, we need to go here. Then we have the font face. So cv2.font. Let's pick italic, and then we have the scale. So this scale is supposed to be dynamic. So, but for now we will just put any random scale. Let's say 1. And then what do we have? The color. The color we will keep as white. So because the background is black, you can change it if you want. And the thickness, let's put it at, let's say 2. So let's push it down here. And let's run it. Let's see what happens with the text. Oh, we are putting it in the wrong image. It should be image text. Okay, so there we have it. Okay, we have some issues. So this is good by default, or maybe it's a little bit bigger for default because it's already covering up a lot of space. So we need to remove the space from a few of these. Let's remove those. There you go. So now it should be fine. There you go. So now if I go back, it should increase. If I move forward, it should decrease. So we need to add the dynamic value for our scale. So this is the value that we have right now. We have to add the scale value. So let's write here scale equals to, we will start with the bare minimum. So it will not go below that. So let's say 0.4. That's the minimum it will go. Then we will add a certain value to it. Now, what we can do is we can check our values. So when we are running it, we are getting these values 62, 70, 58. These are in centimeters. So we need to add some value here, maybe 0.1, 0.2, 0.3, something like that, not big values. So we will take in this number, which is basically the distance or the depth, and then we will divide it by, let's say, 100. So if we divide 51 by 100, we will get 0.51. And then this will become 0.9, the total value. So that makes sense, right? So we can copy this and we can paste it here as the scale. Scale can be floating value, so it's not a big deal. So let's run that. And there you go. So if I go forward, you can see something is changing. If I go backwards, something is changing, but the effect is not very clear. When we are changing the size, apart from what you call these values of the scale, we also need to change the single height, because if the gaps between the lines are same and the other element keeps changing, then it looks bad. So what we can do here, we can start from, let's say, 20, and then we can add again. This time we will divide the D by, let's say, 5. So let's try that. Single height, this needs to be integer. So we will write integer. There you go. So if I go closer, it becomes smaller. If I go back, you can see it keeps getting bigger. If I come closer, backwards, there you go. So if you want to have a bigger effect, you can reduce the value here. Let's say you can divide it by 80 instead of 100. So now if I go back, it will become bigger quickly. There you go. So this is the idea, and let's reduce it to 50 and see what happens. And we should, if we are reducing that, we should reduce this as well. So let's say 2. Yeah, that's really big. So it's going out of the picture. So if we go back, there you go. So let's make it 4, and let's make this 75. 75. Yeah. But here you can see the issue right now is that it is becoming bigger and smaller, but the issue is that it is jittering a lot. So we don't want that shakiness. We want to have a smooth transition. So what exactly can we do here? What we can do is instead of changing every single time, we can increment, for example, 0.1. If it's, let's say, 0.5, we can increment only to 0.6 or 0.7, then 0.8. We cannot increment to 0.41, 0.42. So it will increment with the numbers of 0.1, let's say. So how can we make sure of that? What we can do is we can multiply the d, which is your distance. We can we can divide it by, let's say, the value of 10 if we want that increment, and then we can convert it into integer. That will remove the decimal place, and then we can multiply it again with 10. It might be a little bit confusing, but you will see the effect now. So now it will only increment with 0.1. So if I go back, there you can see it is a little more stable now. If I go forward, if I go backwards, you can see the distance is changing. So now if you still think that it's a little bit jittery, you can put 20 instead of 10, and that should work as well. And we can do the same thing over here. So, and then we have to divide it by 4 and then make it an integer again. So let's try that. Oh wait, we are dividing it by 20, then we need to multiply it by 20 again. My bad. Okay. What is wrong here? There you go. If I come closer, you can see now it changes only after 0.2, which I think is not that great. So let's put it at 10. I think 10 was good. Actually, let's make this as a variable. Let's call it sensitivity. So we can give it the value of, let's say, 10. More is less. So more is less sensitive. So that's the idea. So here we will put this sensitivity value, and there you go. So right now it's 10, like we did before. There you go. I think this is good. Yeah. So it looks good and it works fine as well. So again, if I keep moving my head, it might keep changing. So you can fixate, like for example, you can move only after 0.3, 0.4. You can change the sensitivity over here so that it only has maybe 3 transitions, and that's it. So that is up to you. How much detail do you want it to be? So that is basically our project for today. And you can use this in many different applications. And as you can see, it is quite simple to add it with a project as well, once you have the distance and you have all the measurement. Now, what you can do is You can also try this face depth measurement with other measurements of the face. And you can also do the same thing with objects. But given that the object has a constant size. So if you are in a factory or somewhere where the conditions are controlled and you know some variables, then it can be very useful in those situations. For example, if you are finding A4 papers, so you know the dimension of the A4 paper, then you can tell the distance between that. So some other objects that you know the distance for, then you can use that to your advantage, and you can use this focal length method to actually find the depth of that object from the camera. So this is basically today's project. I hope you have learned something new. Let me know in the comments what would you like to see next, and if you really want to level up your skills, do check out our premium courses on our website, and I will see you in the next one.